Welcome to Andes RISC-V webinar. This is Simon Wang. Today, I'm going to introduce Andes software solutions to accelerate RISC-V AI and IoT development. In this webinar, we will provide an overview of Andes software solutions, including AndeSight IDE, AndeSoft DSP, and AI software stack that includes programming with RISC-V DSP SIMD extension and Vector extension. Then we will focus on NN development with NN library and couple use cases of NN models. Before we started, I believe there are some audience who may not be familiar with Andes. So I'm going to give you a short Andes brief about who we are. Andes Technology is a 16-year-old pure-play CPU IP public company with headquarters in Hsinchu, Taiwan. We are a RISC-V founding and premier member and very active in RISC-V International. We are also a major contributor and maintainer to open source ecosystem. With many years experience in CPU industrial and very strong R&D team, Andes has over 200 licensees and about 20K installations of our AndeSight IDE and over 7 billion total shipment of Andes embedded SoC. Okay, let's jump into today's main topic, AndeSight IDE, the comprehensive development environment. AndeSight IDE contains AndeSoft DSP and includes the following features: user-friendly and easy-to-use IDE, highly optimized GCC and LVM toolchains for outstanding performance and compact memory footprint, abundant demos for boosting your development, and also rich RTOS and Linux, which is verified by Linux test project. We have optimized compute library such as DSP and Vector, and peripheral drivers for AndeSight platform. We also provided near-cycle accurate simulators, AndeSync, and Arduino support for the AndeScope EVB. And we are glad to announce here the new AndeSight IDE version 5 is ready to launch in this June. Let's see how it works when users develop the SoC software. After installing the AndeSight IDE, user can build applications based on AndeSoft DSP. Then deploy to the AndeSight EVB via AndeSight Pro, or simply execute the application on the AndeSync or AndeSync virtual platform. In a single graphic user interface, you can do all the development, building, executing, debugging, tracing, and profiling the software. AndeSight IDE is Eclipse-based, and it is enriched for 17-year continuous development. Besides the basic features provided by Eclipse, additional features are rolling out in the past. For example, the B-field display. The IDE will show the register information in the B-field level at runtime. Functional profiling, which shows the ratio of the total consuming time for each function. And it's very useful when optimizing the software. Meta-link script editor. We know the link script for embedded software is really annoying. With this feature, developers only need to write a concise version and let the tool do everything else. RTOS awareness is along with each RTOS supported in AndeSoft DSP. It indicates the status of each task, which is running, suspending, or idle. It also indicates the status of inter-task communication. For example, is there any waiting message in the queue or not? Custom plugin, which allow users visualize any memory or register data they are interested in. For example, this is visualized data from ADC. Function code size, a useful feature that figures out the code size for each function. Okay. Moreover, besides these classical features, we will introduce more new features in the coming AndeSight IDE version 5. We just talked about ATOS awareness. Developers can gather ATOS data when breaking the applications set by setting a breakpoint. But how does it work if we cannot narrow down the issue to set out a serious breakpoint? How can I know if the software is working correctly in a period of time? Talking to FreeRTOS. FreeRTOS Timeline Analyzer can visualize the runtime execution behaviors of tasks, interrupts, and events within a period of time. As you can see, you can record information from FreeRTOS execution. IDE Timeline View will show the task on context switching along with the time, and it is linked to the source code and the event table as the second picture. Statistic View, the third picture, shows the write count, the run frequency, and also the less runtime, the minimum runtime, the total runtime. Developers can trace them and check if the software behaves as their expectations. Talking about multi-core development, it is very easy in AndeSight IDE to build and debug multi-core software with separate configurations by simply creating multi-core projects. Developers can debug each core separately in a single IDE. You probably are curious if part of cores are actually a single group for the applications. Can I debug and control the cores in the group at the same time? The answer is yes. Developers can group the cores as they want. The debug commands can send to a specific set of cores at the same time. AndeSight scripting. Replay UI operations are very welcome for many use cases. For example, the QA division would like to do the test automation. Engineers will be easier to reproduce issues with an issue producing script. Okay. With AndeSight scripting, it is also very easy to record the UI operations by simply push the stop to record button. And doing the operations you originally planned to do. Then the IDE will automatically record and generate the Python script. Then you can export it and let someone who is interested to replay the operations. AndeSight BSP, the application building block inside of AndeSight IDE. Let's look at some details of the BSP. First, about the fundamental part. And it supports the GCC and LVM compilers, and also the optimized standard C library as well, such as MCLib, NewLib, and glibc. We also support the optimized compute library for NN, DSP, and Vector processing. The fast and near cycle accurate simulator, such as AndeSync, AndeCC, and QEMU. For the debugging, GDB and Iceman, which is speed optimized OpenLCD. And we also support concise linker script and its tools, the LDSEC, and bare metal drivers and demo programs to demo the AndeSight core features. For the ATOS, we support the open source ATOS like Zephyr and FreeRTOS. There are also commercial ports on Andes, such as Azure ATOS ThreadX, LightOS, ArtistThread, and Silis OS. There are several RISC-V ready ATOS, and so on. For the Linux middleware and software framework, we support Linux kernel version 4.17 and the long-term support version for 5.4. Device drivers and couple advanced features. For the bootloader, we support U-Boot, OpenSBI, and BBL. For the bare metal applications, there are rich star demo projects for any specific features, such as interrupt, click, memory, the MMU, PMP, physical memory protection, PNA, physical memory attribute, and cache operation, ECC, bus matrix slave port. Some demos for the power management, the power brake, the power throttling functions, HyperNet, WFI, CPU standby and resume. For the programming, there are DSP, printf with UR redirect, C++ programming, and also stack safe, the stack protection, performance monitor, and SMP programming. For the MC drivers, we supported DMA, Flash, GPIO, I2C, P.M, RTC, SPI, UART, and Watchdog. About the Linux, from AndeScore 45 series, it is mainline Linux compatible, and all the Linux ports are verified with Linux Test Project. For the advanced kernel features, Strace or fstrace is for you to easily debug Linux applications. The performance monitor to evaluate the system bottleneck. Power management such as suspend to run, which is a function you can suspend by sysfs interface and wake up by real-time clock or UR interrupt. Power brake, the power throttling functions controlled by sysfs interface. And we also support kernel module, high memory, and CPU plug features. For the Linux distributions and build systems, Andes has verified Fedora, Debian, Yocto, OpenDAO-RT, and Beirut. There's also Andes Lab service for the customer under the maintenance program. Our customers can fetch the source code, integrate with CI infrastructure, and develop Linux software based on Git service. The following section, we will introduce DSP, Vector, and programming with couple and model use cases. Okay, this is an overview of AI software stack and ecosystem. How do we map the AI applications to Andes core? First, on the left-hand side, an AI application is usually along with pre-processing and post-processing for the audio, voice, video, and image data. So solutions such as OpenCV, OpenVS, or couple codec and audio front-end solution. Second, for the NM model, from training an NM model with AI frameworks and optimizing the model with offline tools, then you need to execute an model on inference engine, such as TensorFlow Lite, TVN, Glow, or other third-party solutions. The Andes part, Andes support LVM compiler to generate RISC-V DSP sync DP extension and RISC-V vector extension for both sides, the signal data processing and inference. Also, Andes OpenCL enables the parallel programming for heterogeneous system. And with the optimized Andes DSP library, Vector library, and NN library, it boosts the performance further for the competitive products. Andes has implemented the first RISC-V DSP CDP extension processors, short for RVP. We also lead the RVP task group, contribute our knowledge, and consolidate the standard with RISC-V community. For the RISC-V P extension programming, the intrinsic function, a C-like functions without writing error-prone assembly. The AndeSight DSP Library, it is about 300 functions in 10 categories, such as basic, complex, controller, distance, filtering, matrix, statistic, SVM, the short for as support vector machine, transform, and utils. Generally, it increases power efficiency to DSP applications, about 2 to 5 speedup of RVP over RISC-V baseline instruction for codec, and 8 to 14 speedup for ERM models. Andes DSP Library. It is the optimized low-level DSP functions for RISC-V baseline and RVP processors. It is compatible with CMC DSP API, and the compiler can auto-generate partial RVP instruction to facilitate development. It boosts the signal processing performance, and in general, about 3 speedup of RVP over RISC-V baseline instructions in average of all functions in DSP library, and around 22 speedup in maxima of all functions. The standard software solution in AndeSight IDE includes AndeSync, the new cycle, nearly cycle accurate simulator, toolchains, the intrinsic functions, a C-like functions without writing error-prone assembly. AndeSight Vector Library. It is optimized for RISC-V baseline and RVP processors. It is more than 100 functions in 5 categories, such as basic, filtering, image, matrix, and transform. And it's also compatible with any 10 library API. There are more advanced software solutions, including AndeSight, the consistency support for AndeSync, Andes Clarity, the GUI-based processor pipeline, visualizer, and analyzer. Andes Library, it is optimized. It is an optimized neural network functions. RISC-V vector extension is very powerful for data processing. As you can see, the speedup of RVP over baseline. You can focus on the yellow bar, which is with the configuration of VLAN 512 bits and SIMD with 256 bits. For the add operation of F32 data type, it is about 22 speedup. And the convolution of Q7, it is about 32 speedup. And general matrix multiplying of F32 data type is about 43 speedup. Relu activation of Q7 about 80 speedup, and mobile Navy 1 is about 66 to 68 speedup. It is very impressive. Let's talk about the Andes Clarity, the processor pipeline analyzer. As you can see, for the MAC instruction for floating, the IDE visualizes the pipeline store bubbles, which come from the resource conflict of the FMAC hardware function unit. With the Andes Clarity, you can optimize pipeline usage much easier. Actually, Andes internal teams use it a lot when developing in-house software solutions, such as Vector Library and AI Library. It is the optimized neural network function for PLC, RVP, and RISC-V processors. It boosts NN performance by using SIMD and Vector instructions. There are over 120 functions in 8 categories, such as activation, basic MAC, concatenation, convolution, fully connected, pooling, softmax, and utils. And it is compatible with Siemens SN API. In general, the performance is about 6 speedup of RVP over RISC-V baseline instructions in average of all functions, and around 25 speedup in the maximum of all functions. Here's an example for an Model Inference with TensorFlow Lite microcontroller and AndeSight Library. First, on the PC, we train a model from TensorFlow framework. Then we get a model with TF-Lite format. Second, we can optimize the model with end-of-life tools such as pruning, quantization, and so on. Third, we compile the optimized model with the TensorFlow Lite micro runtime and the built-in reference kernels. Then we can get an executable to be run on Andes RISC-V processor. Fourth, to utilize the RVP and RISC-V hardware performance. Instead of the built-in reference kernel, developers can use AndeSight Library to get outstanding performance. This is the summary table of the Library API. Developers can implement most of the popular CNN models with Library. The activation, the operators such as sigmoid, hyperbolic tangent, ReLU, and liquid ReLU. For the basic, like element-wise operations, concatenation, convolution, such as convolution 2D, point-wise convolution, depth-wise convolution, and fully connected, pooling, maximum pooling, average pooling, softmax, and some kind of utils like reshape. We are going to introduce 2 use cases. The first one is CIFAR10. There are 5 levels in total in CIFAR10 model. The top 3 are all combined with convolution, activation, and pooling. The last 2 are fully connected and softmaxed. All you need to do is to write a main function called the Library API sequentially and make sure the function argument fill in correctly. Use the N4 as the base and is the 25F, which is a 5-stage pipeline, 32-bit RVP processor. It achieves 3 speedup over M4. And is the 45, which is a 8-stage pipeline, 32-bit RVP processor. It achieves around 4 speedup over M4. And is AS25, which is 5-stage pipeline, 64-bit RVP processor. It achieves around 4 speedup over M4 as well. The performance boost with Andes Library increase the power efficiency and get a lower response time. The second use case is MobileNet V1. On the right hand side, you can see the MobileNet V1 model architecture by layers. Similar with CIFAR10 model, it's not hard to implement the model with an library. On the left hand side is the inference latency performance table. The lower the better. To be noticed, the top 4 are real cheap performance. You can get it from the public TV and GitHub. And we normalize to 1 GHz 1 core in order to compare the performance easier. Let's look at it. And this NS27V, which is a RISC-V processor with VLAN 512 bits and sync with 256 bits. The latency of single one image inference is about 62 milliseconds. When scaling to 1 GHz one core, okay, it means the frame rate is about 16 FPS at 1 GHz one core. This is the number for half precision floating data type. If we simply multiply by 2 for single precision floating, the latency will be about 112 milliseconds for single one image inference at 1 GHz one core. It is better performance than CA9, CA53, CA72, and CA73. Okay, about the Andes ecosystem. As we know, ecosystem is very important for the AI applications. Each layer or each function block of the software stack could be the performance bottleneck for the whole system. We need and we are happy to have a third party to join, improve, and finally deliver the value to the end customer. AI used to be the key compiler and IDE vendor in ecosystem. Now it joins the RISC-V and provides outstanding compiler performance for RISC-V processor. It supports all series of Andes RISC-V CPU, and we also partner to provide processors and toolchain for functional safety applications. IR has certified for functional safety for the industrial, automotive, railway, and medical devices, and it will deliver processor for functional safety as well in 2022. Andes FreeRTOS support on AndeShape CoVAP 1 and 25 EVB is qualified by AWS. Not only FreeRTOS kernel porting, the qualification program requires integrating with networking stack such as Wi-Fi and TCP/IP, and security functions such as public key cryptographic standard and TLS, and the message protocol MQTT. The verified program runs on device and cloud as well to examine the AWS and IoT functions executed correctly, smoothly, and consistently. Now, let's quickly summarize today's talk. AndeSight IDE, the user-friendly and easy-to-use IDE, which accelerates your RISC-V software development. AndeSoft BSP, highly optimized toolchains for better performance and smaller memory footprint. The well-integrated building blocks to reduce time to market. AI software stack boosts the performance for RISC-V AI and IoT applications with optimized AndeSoft DSP, Vector, and NN libraries. In the last page, there's an AndeSight IDE free download program. You can scan the QR code and download the previous version for evaluation. It is 3 months time limit. Okay, this is all for today's webinar. Thanks for your listening and hope you're having a good day. Thank you.